All right, so the 6-1 to 6-3 review. So you have a bagel shop, number one, that has 3 types of bagels. Plain, onion, raisin, doesn't really matter. Each bagel can be ordered with no spread, 1 topping, butter, 2nd topping, or cream cheese, a 3rd topping. Okay, how many different combinations could you order? Well, if you went with a factory tree, which can, like I said before, can get messy, you would have, your 3 different types of bagels. And each one could have 3 different toppings on it. So you can see that that's 3, 6, 9, okay? But the easy way is just the counting principle. There are 3 types of bagels, and there's 3 types of toppings. Much quicker than a factory tree, all right? And that's 9 different ways, okay? New car is available in a sedan and a hatchback. That's 2 different models. There's 7 different colors, and there's 3 trim levels. All you do is simply multiply those numbers, 42 different ways. Now, number 3 is getting to the slots problem. This is like when people are lining up for a photo because you have 5 questions. Each one of those has one of 2 answers. So that's 2 to the 5th power, which is simply 32. So there's 32 different ways that could be answered. The volleyball team must choose a captain and a co-captain out of 5 players. How many different ways can you choose the captain and the co-captain? Now remember, this is one like we did recently, where even though it sounds like captain and co-captain are similar, okay, they seem to have equal power, it's still a ranking because this is like captain and really an assistant. They're the co-captain, okay? So they still have a ranking. So that's going to be 5 players, ranking matters, picking 2. So we're going to go to the calculator. That's not the calculator. This is the calculator. We're going to reset the calculator. And we're going to do 5, math, PRB, and PR 2. That's 20 different ways. Okay? Now, remember, just for comparison, if we did NCR, where order does not matter, it's going to be smaller, okay? Because you're dividing by more numbers in the formula on the bottom. So the answer is 20. So remember, this is kind of a tricky one, but this is still a ranking. So it's permutation. All right, a family with 2 teens, 2 children, and an infant are getting ready to have their picture taken. How many different ways can the kids, just the kids, not the parents, be lined up for a photo? Well, there's 5 kids, 2, 4, 5. Okay? So that means there's 1, 2, 3, 4, 5. Okay? There's 5 kids that could be here, 4, 3, 2, 1. This is also 5 factorial, if you notice that. So it's a little bit quicker. Instead of, you can do this in your head. 5 times 4 is 20, then 60, then 40, and then 120. But it's a little quicker if you use the 5 factorial key, and you'll get 120 different ways. Now, what if the mother wants the teens on each end, but doesn't care about the others? Well, here we have 1, 2, 3, 4, 5. So she wants one of the teens on this end. So there's 2 teens that could be there, but there's only 1 teen that could be there. Because once the first one is in the first spot, there's only 1 on the end. And doesn't care about the others. All right? Well, at this point now, there's 3 kids left, 2 kids left, and 1 kid left. So that's 2 times 3 is 6, times 2 is 12, times 1 is still 12. What if the father wants the infant in the middle but doesn't care about the others? Okay, well, 1, 2, 3, 4, 5. There's only 1 infant, so that's easy. Now, how many kids are left? 4, then 3, then 2, then 1. Once you get used to the pattern, how to approach it, it's really pretty easy. And if you think about it, you have a 4, a 3, a 2, and a 1. That's really just 4 factorial. That's 24. But you can probably also just do it in your head quicker than going to the calculator for 4 factorial. All right. Parental codes for my kids' Kindles consist of 6-digit numbers. Okay? No digit may be repeated. How many different codes can be used if they have to try to guess it using digits 0 through 9? Okay? So, since there can be no repeats, okay, and order matters, there's actually 2 ways to do this problem, but let's go to slots. It's kind of pretty basic. You have six possible numbers, 1, 2, 3, 4, 5, 6. Now, there's 10 digits, 0 through 9. If numbers could repeat, you have 10 numbers that could go here, and if they could repeat, then each one of those slots would be 10. But once you use one of the numbers, if there's no repeats, this is simply 9, then 8, then 7, then 6, then 5. And if you multiply those numbers, you get 151,200 codes. But another way to do this is actually just a permutation problem. 10 NPR 6 will lead to the same answer. Okay? Now, what about if they figure out the first 2 digits? Okay? Well, in this case, I'm going to go back to the NPR. We're only dealing with now 4 digits. So we end up with 5,040 ways left. But again, you could do this with slots. So really, if 2 digits are already taken care of, we're not worrying about those. Okay? That means we have 10 times 9 times 8 times 7, which will also lead to the same problem. Okay? All right, moving on. Evaluate 123 over 120. Again, if you try to put this in your calculator, it's going to blow up. But remember, once you get to 100, this is 123, 122, 121, 120, 119, 118. But once you get to 120 on the top, they all start canceling. So what's left? 123 times 122 times 121. Because once you get to 120, they start canceling. So if you multiply just those 3 numbers, you end up with 1,815,726. Same thing here. The top is going to be 32 times 31 times 30, 29, 28. But once you get to 30, they cancel out. So it's just 32 times 31, which is 992. All right. The Miss America pageant has 50 contestants. A little difficulty talking there. Contestants. They choose 4 runners-up and a winner. How many possible outcomes are there for the entire pageant? Okay, well, all right, so there are 50 contestants. Order obviously matters, so there's an NPR. And we're talking about 4 runners-up and a winner. So they're choosing 5 different, winners, basically. So we go to our calculator. We do 50, math, PRB, NPR, 5. So that's 251,200. Quite a few. Now, once the top 10 are chosen, how many ways could they finish? Okay, so that's 10 people now they're choosing from, and they're doing 5. So we're going to do 10 math, NPR, 5. 30,240. Once the final 5 are chosen, how many ways could they finish as 4 runners-up and a winner? So that's going to be ranking again. There's 5 possible spots. So that ends up being 120 different ways. All right, how many different ways can 7 classes be arranged for a student if they want PE to be their last class? So what they have is 1, 2, 3, 4, 5, 6, 7. But the last class is already picked. Therefore, there's 6 classes here, 5, 4, 3, 2, 1, which is really just 6 factorial, which is 720. Student council selecting officers. There's 22 seniors and 19 juniors. The president, secretary, and treasurer must be seniors. So there's 3 spots that must come from the senior group. Vice president, historian must be juniors. So there's 2 spots that come from there. How many different ways can they be filled? Well, there's 22 seniors, it's ranking, and there's 3 spots. There's 19 juniors, it's ranking, and there's 2 spots. We're going to multiply those out. So find this number and multiply, or you can type it in the calculator all in one fell swoop. That's going to give you 3,160,080 different ways. How many distinguishable ways can you rearrange the letters in the word day? Well, that's simply just 3 factorial. We don't have to make a word that matters. It's just, that gets you 6 ways. What about the word afternoon? Well, there's 9 letters in afternoon, but there's some repeating letters. There's 2 N's and there's 2 O's. Okay, so once we calculate that out, we get 90,720 ways. What about the word uncopyrightable? Well, as crazy as that looks, there are no repeats in that word. So that is just a 15-letter word, 15 factorial, which is going to be huge. So I'm going to start here. 000 368 674 307 and 1. So that's 1,307,674,368,000 different ways. All right. What about the word bookkeeper? Well, there's 10 letters in bookkeeper, and there are 2, 2, and 3 repeating letters. So that gives us 151,200 different possible rearrangements. All right, last page. How many different ways can you answer a 10-problem true or false test by marking 5 problems as true and 5 problems as false? So this is kind of like the same problem that we just did with repeating letters, all right? So we're going to have 10 questions, but there's 5 repeats here and 5 repeats here. So that gives us 252 different ways. Binary numbers are written with only ones or zeros. How many different 6-digit numbers consist of 4 ones and 2 zeros? So again, we're specifying. So we have, again, 6 numbers. We have 4 repeats here and 2 repeats here. That gives us 15 numbers. A baseball team has 16 players, 12 position and 4 pitchers. The manager is trying to get his starting lineup of 9 batters. Okay. Well, right here, we have 16 players. We're picking 9. That is NPR because it's positions. Okay. Because the pitcher's going to bat. That gives us 4, 1, 5, 1, 3, 4, 7, 200. So 4,151,347,200 different lineups from just 16 players. It's crazy. How many arrangements could be set up if he wants a pitcher to bat last, but doesn't care about the rest of the other position players? Okay. So the other position players, there's 12. Okay. And that gives us 8 here because one has to bat. One of the pitchers has to bat. There's 4 pitchers. He's batting. Okay. So again, 8 plus 1 is 9. 12 plus 4 is 16. All right. And when we multiply those numbers, we get 79,833,600 lineups. How many arrangements could be set up if he had already chosen the first 4 position players and he wants the pitcher to go last? So the pitcher going last is the same thing here. Okay. But in this case, he's already picked 4. So that just leaves 8 here. And he's filling 4. So same idea as up here, except it was all 12 with 8 positions left. All right. This is 8 for the remaining 4. And that is just 6,720 different possibilities. And last but not least, 19. Same team from 18 is lining up for a team photo. How many different ways could they be pictured? Well, that's just going to be 16 factorial. But it's going to be huge. So it's, whoopsie. 20, 922, 789, 888. That's not 8. 0, 0, 0. Huge number. How many ways could they line up if there are 2 pitchers at each end? Okay. So kind of like before, we got 14 people going for 12 of the spots and 4 people going for 2 of the slots. Okay. We could also do this with the slots problem. Okay. Where we put the pitchers on each end and then fill in the numbers in between. This is just a shortcut to that same process we did at the beginning. Okay. That ends up being 523. That's supposed to be a 3. Sorry. 069. 747,000. That's a 7. 200. Again, that could be done with slots, but it'd be pretty large, filling it in. And last but not least, how many ways could they line up if there are 2 sets of identical twins and a set of identical triplets that no one can tell apart? Well, again, there's 16 players. There's 2 sets of identical twins and 1 set of triplets. And that leads to 871 billion 782,912,000. And that is